This Razer Blade 18 has an NVIDIA RTX 4090 in it. How do they fit it into such a tiny laptop? Well, it's not the same at all as a 4090 desktop version, which I've got right over here. Needless to say, they don't perform the same, not even close. And if you're gonna be running large language models on these or other AI workloads, the difference becomes even more obvious. So in this video, I'm gonna do the tests. Inference speeds, VRAM usage, real world workloads, so you can decide which one makes the most sense for you. Yes, they're both called the 4090, and this is something NVIDIA has been doing for a few generations now. With the 3000 series, the 4000 series, I'm sure they're gonna be doing this with the 5000 series. They don't designate the mobile version of the 4090 with the little M like they used to, so it has potential to really confuse consumers. And they are quite different. The desktop version packs 68% more CUDA cores and can draw up to 450 watts of power, enabling higher clock speeds and better performance, while the laptop version maxes out at just 150 to 175 watts, depending on the OEM or the manufacturer of the chassis. Memory is another major difference. The desktop 4090 has 24 gigs of VRAM. That's GDDR6 memory with a wider memory bus that's critical for running things like LLMs, although you'd still be kind of limited to the smaller LLMs unless you quantize them. I'll get into that later. And the laptop is limited to only 16 gigabytes. On top of that, the desktop benefits from 16 lanes of PCIe Gen 4, while the laptop is capped at 8 lanes. And this also can create bottlenecks in AI workloads. So going by these spec differences alone makes the desktop GPU far more powerful, and it seems like it's going to be better for running large language models, right? Well, that's not always the case, especially in the case of portability. We'll get into that shortly. So why does memory matter for LLMs? Well, when running large language models, VRAM, or the RAM that's assigned to the video card, is critical. Larger size models like the Llama 70 billion parameter model, they demand massive amounts of memory to run. Usually the desktop GPU can handle these workloads pretty comfortably, allowing for higher batch sizes and smoother performance without quantization. But on the other hand, the 16 gigabytes in the laptop is going to make you struggle a little bit more, and still allow you to run smaller models or higher quantization models like 4-bit or 8-bit, but the more quantized your models are, the more performance of the LLM degrades. So if you need to load bigger models or run inference without cutting corners, the extra memory on the GPU makes a huge difference. And that's why machines like the MacBook Pro with almost 128 gigabytes of unified memory available for the GPU is quite popular with the machine learning community, especially for its price point. There's not a video about that, but I do have other videos covering this topic specifically on the Macs. Now, to keep things kind of fair as I can, I've set up these systems with pretty much the same exact software stacks. The laptop is a Razer Blade 18 with an Intel Core i9 14900HX, 14th generation HX processor, 24 cores. That shouldn't matter that much because most of the workload is going to be on the GPU. However, if the machine runs out of VRAM or graphics memory, then the software that's running the LLM, some of them will automatically transfer the rest of the workload, the rest of the layers that don't fit to the CPU, which will still not crash your machine, but it'll perform a lot slower. So that does play a role. Now on the desktop side, I have something slightly different. It's not a full-blown desktop, but it will do the trick to demonstrate the power. Driving this capability, I have a mini PC, and this is a Ryzen-based machine from GMK Tech. It's called the K8 Plus, a really nice little mini PC, lots of options in it, lots of I/O, USB 4, but here is the kicker right here. It has something called an Oculink port, which are not too common these days to find. Some machines have them, and the machines that have them can take awesome advantage of higher bandwidth because you can use an Oculink based dock, and I made a separate video on this. All you gotta do is just plug in this Oculink cable into the machine, and I'm not gonna do it right now because Oculink needs to be powered off. The system needs to be powered off before you plug in the cable, just to make sure everything, is on the up and up and doesn't explode. And here I've got a Minisforum dock. This is the DEG1, which houses a power supply and an RTX 4090 from Gigabyte. I'll talk about the pricing of these systems a little bit later in the video. I'll have you know, though, that this is not the full speed of an RTX 4090. Rather, it's going to be capped at what PCIe 4 is capable of which is going to be up to 64 gigabit per second transfer rate via Oculink, which is going to be fast enough to show some differences. However, if you house this in an actual desktop on a PCI slot, you're going to get even higher performance. To begin with, I'm going to use a popular tool called Llama. If this is new to you, just go to ollama.com. It's really easy. All you do is click on this download button, pick Mac, Linux, or Windows. It works on all those. It installs the program and kicks it off. It's going to be running in your little system tray right here. But if you want to run it, you're going to go to the terminal and write Llama run, and then the model name that you want to run. Now, I have an entire tutorial on how to set up a UI, kind of like ChatGPT with Llama. That's also on the channel. I'll link to it down below. But we're going to use it through the terminal for now, just to make things simple. The models that you can run are available on ollama.com on the models page. Lots of different ones here. Llama 3.3, 3.2, Mistral, Llama, Qwen, and so on. Let's start with a really small model, and that's Qwen 2 Coder. Here we go. Qwen 2.5 Coder, 0.5 billion parameter model. So only 500 million parameters. This is the command right here. All you do is copy this. You select the size of the model you want right here, 0.5 billion. And down here, you'll see the quantization level. There are going to be different quantization levels, and that makes a difference. So for example, the 7 billion parameter one is quantized to 4 bits, and the 0.5 billion parameter one is quantized to 8. So it's not going to be super consistent. You're just going to have to check over there which one is downloading. And this page gives you a nice little command to run on your terminal. So all we do is copy that, come back out to the terminal. You can type it out, or you can just paste it in. Llama run Qwen 2.5 Coder. And then I like to add a -- verbose flag, which will show you how many tokens per second you're getting, and just a bunch of other stats. I've already downloaded this. It's not that big. It's only about 500 megabytes. And if you're downloading this for the first time, it's going to take a minute or two to download it. However, I've already downloaded it, so when I run it, it pops up instantly. Send a message. Okay. Hi. Boom. This will warm up the model. Okay. 38 tokens per second. That's not good. That's not good at all. What's going on here? Let's go with write a 1,000 word story, and boom, there it goes. It's writing the story. It's going pretty fast now, I'd say. And the fans kicked in, and I think that something is wrong. And this will give you an idea of what happens with these higher quantized models that are small. They're not too smart, so they might get stuck in a loop, and that's exactly what happened here. I'm gonna pause this. As he finished writing, finally Jack decided to write another paragraph for his son. So it's now in a constant loop. You have to terminate this process, and that's not the best experience. We still don't have a definitive answer to how many tokens per second this is, but we do have a couple things. Let's try that again. Okay, so you'll see that, oh, it's done with this one. This time it decided to finish. 309 tokens per second, which is really fast, but that definitely was not 1,000 words. Let's try it again. Yeah, now it's giving me things like, as an AI language model, I cannot provide you with a story. So this model is totally just kind of not very useful. It does have a high token per second though. Now, when I warmed this up, it did give us a couple of pieces of information. If we take a look at HW info, you'll see that the GPU power, the average is about 27 watts over there, but the maximum is 271 watts. Okay, let's try the same thing, but over here. First, we'll warm it up. High, 217 tokens per second. Write a 1,000 word story. And there it goes. Pretty fast. It's still going really fast. It's not writing a 1,000 word story, but we're getting about 230 tokens per second this time around. And here's a close-up of the GPU power. We have 118 for the maximum for that NVIDIA laptop GPU, and an average 7 watts. So a lot less on average being used. And the maximum is quite a bit less, maybe less than half of the amount of the desktop version. Don't take this out on Qwen 2.5 because that 500 million parameter model is not very good. Their 3 and 7 and 14 and 32 billion parameter models are much, much better. However, a pretty good one that's small is Llama 3.2 1 billion parameter model. And there it is. I'm gonna run it. Boom. Hi. 296 tokens per second. Still really impressive. Write a 1,000 word story, and there it goes. It's actually listening to me. It's writing a 1,000 word story, and it didn't get stuck. 313 tokens per second. Write a 1,000 word story and go. Okay. This is working quite well. This is very acceptable. Very nice. I'm not checking the quality of the writing. Not really what we're here for. I want to see speed, and I want to see that it's not getting stuck and it's actually making sense somewhat. So I'm skimming the text, but I'll save you from the literature lesson here. 225 tokens per second. We're seeing quite a bit less here. The desktop version maintained its level at about 300, while the laptop version kind of went down a little bit. If you issue the default Llama 3.2 model is actually a 3 billion parameter model. So the next step up. Let's check that one out. Okay, write a 1,000 word story. If I hit up arrow, it's just gonna give me the previous prompts that I did and go. I don't know if this is gonna be a race, but I guess it is now. So there we go. And the fan kicked off here, but it finished pretty quickly. This story is about Sophia. This story is about Emily. 201 tokens per second on the desktop version, 151 tokens per second on the laptop version. Now the 3 billion parameter version of that is quantized to 4 bits. And by the way, you can get different speeds, different tokens per second, depending on what tool you're using too. So in Llama's case, that's what we're getting. But if you were to run a tool like LM Studio, for example, a very popular tool, you might get very different results. Here's a Llama 3.2 3 billion instruct model. This one's also quantized down to 4. Let's just get a baseline for what LM Studio delivers for tokens per second here. Write a 1,000 word story. There we go. In LM Studio, you can also select which model you want by searching for it. So I didn't have the same exact model as I had on the laptop. So I'm gonna search for Llama 3.2 3 billion instruct, just so that we're comparing apples to apples here. And once you found your model that you want with the quantization level that you want, you can hit on download. And since we're digging around over here, I might as well show you that if you go to power user or developer down here at the bottom, and then you hit on this developer icon menu option, you can go to LM runtimes and you'll see what's configured. So on this machine, I have CUDA configured, so that'll allow me to run on the NVIDIA GPU. I have CPU, and I also have Vulkan, which will allow me to use the iGPU or the built-in GPU as part of the Intel processor. So for this one, I have CUDA selected because that's what we're comparing. But this is one of those tools that I was talking about that can dynamically allocate a model to different parts. So for example, I start a new chat and I select a different model here. I can say what the GPU offload is. So I can offload all the layers of this model to the GPU, or I can select how many layers I want to go to the GPU. But also if the model is too large to fit in RAM, Llama and this tool will automatically send some of the processing to the CPU. Download complete. Load the model. The model gets loaded into memory. So you'll see the dedicated GPU memory here is 2.6 out of the available 24 on the desktop and 3 out of the available 16 on the laptop. It's the same model, but there's probably other processes that are accounting for the difference there. Write a 1,000 word story. Now it's really, really tiny and it's hard to see, but you can make out that it says 177 tokens per second over there for this model in LM Studio, and it's 95 tokens per second for the same model in LM Studio on the laptop. So this is a pretty big model and it takes a while to download, and when you hit to load, this is what it looks like. So you can see that the GPU memory is being taken up quite a bit, but not nearly full on this desktop GPU. Now here on the laptop, I've downloaded the model. Let's see what happens when I start loading it. So I'm gonna click on load. At this point, the model is supposed to transfer to the GPU. And here we go. It's gonna be a very tight squeeze, even if it works. Or maybe not. At this point, it looks like LM Studio decided that was too much, and maybe some of that went into system memory instead of GPU memory. Now, system memory is 27 gigabytes in use out of the 32 available. Quite a bit there. Let's test this out. If this model did get split up, it's gonna be significantly slower. We'll say hi, say hello to our little friend. Okay. Neither one of them is doing well. We've got 8.8 tokens here on the desktop and 6.3 over here. Write a 1,000 word story and go. What? Look at this. The whisper in the woods The Whispering Woods, Chapter 1, The Arrival, Chapter 1, The Arrival. Weird, right? I mean, it's a little bit different, but still, they're both about Emma. Both of these stories are about Emma. Spooky stuff. Now, you can probably hear that noise in here. It's getting a little loud and a little warm. Let's take a quick peek here. GPU utilization is pretty low, 15% on the desktop and 37% on the laptop. Definitely more GPU that can be saturated if it wasn't for that memory limit. Taking a look at the fan output there, it's pretty toasty. We're at 46 degrees on the laptop, but the desktop GPU seems to be staying pretty decent, around 41 degrees at the hottest spot. Can you hear me? Is it too loud in here for you to hear me? That, what you're hearing, my friends, is all coming from the laptop. I can hear the desktop GPU spinning, but the fans are so large that they make almost no noise at all. Nothing is bothering me. Here, I'm gonna bring the camera closer to the laptop and you'll hear the difference. And now I'm gonna do the same thing with this one. Now this one is done, and 7.6 tokens per second is not super usable, but I started them at the same time, and this one is not done. In fact, it is crawling now. What that's telling me is that we've offloaded some of that to the CPU, and look at that CPU. It's struggling. The utilization is 85% on this thing. Some of that model processing is going on the CPU, and that's why it's going so slow. And we're gonna see a huge impact here. LM Studio is actually telling us that 22% of this is being processed on the CPU. All right, I stopped it, but this will give us an idea. 4.8 tokens per second, almost 2 times slower than the desktop version, although not as slow as I thought it was gonna be. They're both pretty slow. In this next section, we're gonna talk about power efficiency, and this is where the video starts to make a little more sense, because in order to fit a 4090 into a laptop, you have to make sure it's more efficient. That's why it's scaled down a bit, because the desktop can consume up to 450 watts of power, while the laptop is capped at 175. That's nearly 3 times the power draw on the desktop, which might make you think the desktop is just inefficient, but here's the interesting part. The performance gain scales much higher than the power increase. For example, when running the Llama 2 13 billion parameter model, the desktop GPU generated tokens 60% faster compared to the laptop, despite pulling nearly triple the power. This means that while the desktop uses more power overall, it's far more efficient in terms of performance per watt, delivering more work for energy consumed. I've been coding in chairs that didn't have my back. Literally. Long hours, bad posture, no support. Enter the Sihoo Doro C300 ergonomic chair. It's like upgrading from spaghetti code to a clean, modular design. Here's why it's a game changer. The self-adaptive lumbar support tracks your movements, adjusting automatically, whether you're coding, gaming, or just leaning back after a tough debugging session. Unlike fixed headrests, this one adjusts in multiple directions, locking into place for a perfect neck support, no matter how you sit. Need a break from staring at an error message? Recline up to 130 degrees. Perfect for a quick reboot. The 4D armrests move in every direction. Think of them as the perfect ergonomic extension for your workspace as you ponder your next commit. Breathable wave mesh keeps you cool under pressure, because the only thing that should overheat is your CPU, not your back. The Sihoo Doro C300 isn't just a chair, it's an ergonomic upgrade. Check out the link in the description and grab your Sihoo Doro C300. Your back and your productivity will thank you. Now that we have an idea of how these models differ on these two machines and from each other, will this actually matter when it comes to real-world performance? Well, if you're using this kind of UI and you're trying to have it edit a document or compose an email, then that's fine. What about a coding environment? Sure, you can copy code into the text field and have it generate a response for you that way, but you can also hook this up to a code editor like VS Code, for example, and you want a model that's snappy so it'll respond quickly as you're coding. Let's do a quick setup here. I've done this already for members of the channel. Thank you, members, by the way, for supporting the channel. And if you want to join, there's the join button right down below. Members get extra videos and other things. But here we go. A developer, there's a local server tab here, and you can select the model that you want to load. I'm gonna go with Qwen 2.5 Coder 32 billion. Let's load that model up, and This is LM Studio, but you can also use Llama and other tools similar to that within the coding environment. And then you click on Start here to start the server. Now the server is listening at this port, which is a pretty well-known port for running LM Studio. Let's go to VS Code, and I already have a project here, so I'll just reuse that. Let's go to this file right here. Now, if you have Copilot already installed and working, you should probably disable that so you can see a difference. I'm gonna click on this little Copilot icon, and it's gonna bring up a menu, and I'm gonna say disable completions. So now I have a little strike through to the little Copilot guy, and I'm gonna go to extensions and install an extension called Continue. Pretty popular extension for doing this kind of thing. Let's click install, and now it's installed. So you can find it down here under Continue. This is what the icon looks like. Now Continue will let you use other LLMs that are available in the cloud, like OpenAI, Anthropic, and so on. But you can also use local. Here it shows you an example of how to set up Llama, but we already have LM Studio running, so I'm going to use that. So here I'm going to add a chat model, and for the providers, you can see all the different providers that are available there. Let's find LM Studio right there. Model, I'll set that to auto detect, and click connect. Pretty simple, right? Look, even the API base local host port 1234 matches. So this is a configuration file for setting up and talking to LLMs, and it's already automatically set up for me. How nice is that? So now this should be able to talk to LM Studio running, what am I running? Qwen Coder 32 billion instruct. If I start typing here, def is prime, and then num. Let's see, is it going to help me out here? There's a difference between completions and chat. Completions I found doesn't work that great with local LLMs, but chat works very well. So I'm gonna right click on that and say, continue, fix this code. And there it goes. It's not super fast, but it's doing it. You can accept or reject. I'm gonna accept, and I can do other things here like continue. I can optimize this code or write comments for this code. It is kind of slow, but the benefit is it's not going out to the cloud. It's not sending your code somewhere if you have private code and you don't want to share it. It's doing everything locally on this machine. Is this super usable? I would not use this model with this setup on this machine because it gets really cumbersome and annoying. It works, but every time I do a query, you can see that it gets really loud and obnoxious. Now, let's try this one. Oh, I actually did something wrong when I got such a low token per second count. When I loaded this model, it defaults to 52 out of 64 layers for the GPU offload. So you need to go all the way up to 64 before you load it. And when I did that, now I got 27 tokens per second for the 32 billion parameter model, which is a lot more than the laptop. That makes sense. Okay. Let's head over to developer and let's select Qwen Coder and make sure you do the GPU offload all the way to 64, load model, and start server. So this should be a slightly different experience based on that finding. Let's go to continue, select LM Studio, auto detect, and connect. You might already have one in here. I'm gonna just remove it because I don't want anything getting in the way. I only wanna have one model here to reference. So there we go. Save that, and I'll create a new file here. Def is prime, num. Here we go. Let's see. Fix this code. Oh yeah, that's definitely faster. I like how the fan starts spinning up as soon as it starts doing anything. It lets me know it's working. Let's accept that, and let's do one more round of fixes. Continue and optimize this code. Pretty good, pretty good. Let's do one more thing. Continue and write comments for this code. I just want to have a side-by-side comparison of how quickly this thing actually generates. So this one is seemingly a lot faster, but let's see it side by side. So there you go, 32 billion parameter model. Not completely, but pretty much unusable on the 4090 laptop version and somewhat usable on the desktop version. If you're running smaller models, like under 10 billion parameters, both GPUs perform pretty well. The laptop GPU can comfortably handle these at regular quantization levels and deliver solid token generation rates. This makes it perfectly suitable for lightweight inference or chat applications or local AI tasks like summarization or code generation. However, as you move up to to mid-size models, like 13 billion parameters, the VRAM limitations on the laptop GPU become more apparent. Here you're going to need a more quantized model, like 8 bits or lower, to avoid memory problems, which can slightly reduce performance or accuracy. But there's models now that perform pretty well under 8-bit. If you're not familiar with the word quantization, different models come in different quantization levels. For example, FP16 is floating point 16, but if you get rid of some of that data after the floating point, then you can get down to 8-bit quantized or 4-bit quantized, saving a lot of room in your storage and, most importantly, in memory usage. But what happens when you get rid of some of that precision? Well, you lose a little bit of accuracy. So your model still works, it works fine, it works faster, but it might not give you the best results, depending on the task that you're running, of course. On the desktop with its 24 gigs of VRAM, you can run the medium models at full precision with large batch sizes, resulting in faster inference speeds and more efficient workflows. Now, for large-scale models like 70 billion parameters, the difference is going to be night and day. And I can't wait to test out the 5090, which can fit even larger models. Stay tuned on the channel, I'll make sure I'll test those. Of course, the laptop GPU won't be able to handle loading a large model like that at all. There's simply not enough VRAM to handle it. You'd have to rely on a really heavy 4-bit quantization or offloading some of the layers to the CPU, which will dramatically slow down token generation and make it practically impossible for you to use it. Let's talk about thermals and noise, because running LLMs is a sustained, heavy workload that pushes the GPU hard. On the desktop 4090, the larger cooling system and higher power limit allow you to maintain a lower temperature even under full load. The fans spin up, but they stay relatively quiet thanks to the massive heat sinks and better airflow, especially with an open setup like I have here. The result is that the system stays cooler and performs at higher clock speeds without breaking a sweat. On the laptop RTX, it's a very different story. And even at just sitting here without doing anything, you can probably hear the noise of the fan. Limited space for cooling means that fans have to spin much faster to keep temperatures in check, leading to noticeably louder noise levels. Even in this huge gaming laptop like the Razer Blade 18, the RTX 4090 laptop GPU still runs hotter and throttles more under heavy sustained workloads. During inference, you can hear the fans working overtime as they try to manage the heat generated from a 175 watt GPU in such a small space. So while the laptop is impressive for its size, the desktop RTX runs cooler, quieter, and delivers consistent performance for longer periods. Now let's talk about price, because performance is only a part of the equation, right? A full desktop RTX based system is probably going to cost you around $4,000. My system is a lot less. Starting with a GMK Tech K8 Plus, we're at $549. It's on sale. I'll link to that down below if you want it. That's the computer, of course. And you're gonna need a keyboard of choice, a mouse of choice. I'm not gonna include that because everybody already has that anyway. I'm just mentioning it because the laptop has that. Now, the way I set up my system is the dock, the DEG1, is $100. The most expensive part of this is the RTX 4090. Mine cost about $2,000, and my power supply is ridiculous overkill. It cost me about $250. You don't need something like that. Mine handles about 1,200 watts. So I got $2,800 for this, but I'm gonna round up to $3,000 just to round it out. Guess what though? This Razer Blade 18 is not cheap. It's $4,500 retail, and I bought it for $3,800. Now there's a lot of other use cases that this laptop enables, like portability. It's got better speakers, of course. It's got a much nicer screen, which I didn't even include in this price calculation. But I think they charge a lot for that screen because the performance of that machine is not amazing. I made a whole separate video comparing developer workloads on the Razer 18 versus the M4 Max MacBook Pro. I'll link to that down below if you're curious. So from a cost per frame or cost per token perspective when running LLMs, the desktop RTX 4090 offers far better value. Not only does it cost less, but it performs up to 60 to 70% faster in certain workloads, making it the obvious choice if raw performance and value are your priorities. Of course, if you absolutely need portability or have limited space, a high-end laptop like this could be worth the premium. But for most people running large language models, the desktop RTX 4090 gives you far more power for your money. So if you need more raw power and value, go for the desktop version. Portability matters, the laptop is your option. Just know the trade-offs. And if you're considering other efficient options that are sort of portable, then watch this video next. Thanks for watching, and I'll see you in the next one.